I've been a runner since I was 12 years old, and one of my favorite things about running is that the only thing you need is a pair of shoes. But when you're on the track and you're competing, your shoes have a really big impact on your performance. And at the time, when I was a high schooler, racing shoes were complex. They were bulky. They were made out of several layers of foam, mesh, nylon, and rubber, all sewn together. And the way that you'd provide more structure and cushioning was by adding more and more layers. But I wanted something that was lighter, something that was dynamic, something that was nimble. I wanted a shoe that felt like it was like my second skin, something that would allow me to feel like I was running barefoot. So I was a tinkerer, and I loved to design my own things. And so, as with most high schoolers here, I looked forward to snow days, and I spent my snow days working on this one project. I set out to actually design a racing shoe. And I started off by taking a single piece of fabric and folding it around my foot in an origami fashion, using actually seams to follow the contours of my foot to provide structure where once plastic and rubber stood. While my understanding of the body and the foot was very rudimentary at the time, and my only tool was my sewing machine, it really enabled me to have these constraints to make a very simple and seemingly elegant product. It resembles a ballet slipper, as you can see here. But this thing is super light. And it allowed me to run much faster times in high school. Now, this process of actually designing clothing around the body captivated me. This is something I was extremely interested in. And I extended it beyond footwear to actually clothing that I could wear on my weekend campouts as a Boy Scout. It was everything from sleeping bags to rain jackets to backpacks. Everything focused on understanding how my body worked and using that to design my clothing. To date, I've co-founded a company called Ministry of Supply, built on that same premise of creating clothing that's an extension of our body, that's functional and really meant for everyday use. We live in an exciting time where fashion technology and wearable technology are terms that are commonly used today. It's part of our lexicon. We've seen how the Jetsons watch has come to life. We've seen how glasses reminiscent of Geordi from Star Trek are now a reality. But in this merger of the digital and physical world, a lot of it has focused on actually extracting data from the physical world and augmenting our reality. But at the same time, manufacturing changes have been made in the apparel industry. But a lot of them have focused on making clothing faster and making it cheaper. A lot of the issues, though, of actually wearing clothing have been overlooked. When you think about our clothing, we still have these issues. We still have sweat stains. We still feel constricted by our clothing, and it doesn't move with us. So what if we could use this technology, this information, to actually help us inspire the design of the clothing that we wear every day? Clothing is something that's really unique. It has this duality to it. It's something that's extremely utilitarian. It's one of the four essentials in life. There's food, water, shelter, and clothing. But at the same time, it's something extremely emotional. It's an extension of our body and an expression of our identity. And for that reason, we can't think of clothing just as a device or a form of art. It's both. We need form and function. But how do we bring these two things together? In the Renaissance, artists and designers looked at figuring out ways that they could understand the human body and use that as a point of inspiration. Engineers like Da Vinci and sculptors like Michelangelo looked at the human body and really tried to find a deep understanding of it by analyzing it in detail. They used this to create designs that weren't possible before. In fact, Michelangelo said, "It's the goal of the sculptor to discover the figure within." And in much the same way, an industry that has done this really well and has really created sculpture out of this is the automotive industry, where we find that the actual dynamics of the vehicle in motion inspire the design of the vehicle itself, where truly the form and function reflect each other. And so in the same way, clothing is sculpture. It is art. And so we need to look at our body as a true point of inspiration for it. But to date, we've designed clothing around static mannequins, or sometimes how the clothing may look on the runway. But what about thermodynamically, how we expel heat? What about our body in motion? What about where our body needs protection? These are all questions we need to start asking when we design our clothing. At the Sports Technology Institute, we're doing just that. We've collaborated with them to understand how we can take principles from the engineering world and apply them to clothing design. Here we're using a process called strain analysis. It helps us understand how, originally in the aerospace industry, how airplanes fly and how their wings deflect under the stresses of flight. We're using that same process to understand how our skin stretches and how it moves. It lets us create a very detailed map about how our skin stretches, but also the direction of its stretch and the magnitude. We're also using techniques like pressure mapping to understand the physics of how our body goes through different motions, understanding the mechanical pressures that are exerted and the forces. And also, we're using thermal imaging to understand the thermodynamics of our garments and our body. It helps us understand how we're generating heat, but also how we're expelling it. One of the interesting things is, as we compile all of this data, the pressure profile, the strain profile, and thermal profiles, we find that we're able to create a very detailed understanding of our biomechanics and our dynamics of our body. One of the interesting things, though, is that when we look at our skin, it's anisotropic. What that means is its properties vary across the surface. And at the same time, when you look at multiple individuals, we're able to find common trends. So how do we bring this to life? How do we use this information? Designers and engineers look at this information and then they articulate it and figure out areas where we can use that information to actually inspire ventilation panels for garments, or areas where we can put stretch panels so that they move with you. But one of the biggest challenges is taking this complex design and bringing it to life. Recently, digital manufacturing and digital fabrication have done just that. We've seen it in 3D printing, how it's enabled us to create a new type of creativity. But I wanted to take a step back before I talk about this new process and look at how we manufacture laptops. This was 10 years ago. This is how I spent a lot of my time, taking apart my laptop and looking at how it was built underneath. About 10 years ago, these laptops were actually made by several pieces of aluminum that were die-cut, stamped, and screwed together. And this is how we created complex forms to hold the laptop together. One of the challenges, though, is we're using a very simple manufacturing process to create a complex object. Fast forward to today, we're now using processes like CNC milling. It's like robotic milling, kind of like carving, essentially, that allows us to take a single block of aluminum and turn it into this beautiful, elegant piece. Here we're using a complex manufacturing process to create something simple and elegant. In the same way, we can apply this to apparel design. And one of the challenges to date in terms of bringing this information to life has been that we've had to use multiple different panels of different mechanical properties or thermal properties to actually allow our body to expel heat, for example. But this results in a garment that looks like it's a patchwork blanket. And so we wanted to find a different way of bringing this to life. 3D printing has allowed not just physical products, but also things like soft goods, like shoes, to actually come to life, where multiple components are all incorporated into one piece. This is where a new process called 3D robotic knitting comes into play. It's kind of like 3D printing, but for clothing. It allows us to take our information, our computer design, and actually turn it into a printed object. These are these machines in action. And what you can do is you can imagine 1,000 needles actually creating different patterns and structures within the garment. We can vary everything from the porosity of the fabric, allowing more air through. We can change the material content, so we can put more elastane where your skin needs to stretch. And we can even put padding where there's high stress points. All of this is enabling us to really bring this information to something that we can wear every day. So I wanted to walk through an example that really brings this to life. And I want to talk about socks. Socks are really interesting because they're the interface between our foot and our shoes. And there's a lot of pressure, there's a lot of heat there, and at the same time, we've always had to compromise. We either choose cushioned socks that provide cushioning and protection, or thin socks that allow us to breathe well, but oftentimes have blisters. You have to choose one or the other. It's a compromise. But using all this information that we have, the strain analysis, understanding how the skin of our foot stretches, or our pressure mapping, we're able to create a sock that actually ventilates in the same areas. Here we created a model and actually printed it in life. Here you can see how we actually have pads right where you'd expect you need cushioning. But at the same time, there's ventilation channels here that allow moisture and heat to be expelled. This is a type of garment that wasn't possible before without understanding the body mapping and having a manufacturing technique capable of doing that. So this is the future of clothing. One of the exciting things is that it allows us to understand how in this new era, we're going to move away from cut and sew garments to ones that are organically inspired, ones that are brought to life by technical manufacturing means. This is going to become a new chisel for fashion designers, allowing them to create garments that are truly an extension of our body. In many ways, we're looking at a renaissance in clothing. Thank you.